So in this series of lectures, we'll be talking about the calibration of audiometric equipment. As an individual involved in any kinds of physical measurement, calibration is important, especially for those who are involved in biometric measurements, like health professionals. It's important that you're confident about the measurements you're undertaking. Calibration is but a process of establishing the relationship between your measuring device and a certain unit of measures. And as a clinical audiologist, a measure would be, for instance, the frequency. You need to be confident that the frequency that your audiometer emits is the frequency that it's supposed to emit. And another measure would be like the decibel. So you need to be confident that the decibel level output from your audiometer is accurate. And so you do that by comparing a device or its output to a standard which has a known characteristics. And that's something simple as like calibrating your weighing machine. For you to know whether it's measuring your weight right, one might buy, like for instance, a 10-pound bottle and place that on your weighing machine, and you expect that your weighing machine to record 10 pounds. So that's again, and if it's off, then you would either make an adjustment physically in the equipment to make sure that it's reading 10 pounds, or you might keep the difference in your mind, and so whatever measurements you're making, you'll add or subtract the amount that the measuring device is off calibration. So and this becomes very important as a clinical audiologist, especially because we depend on the integrity of the instrumentation for us to evaluate our patients' results. So it's essential that the clinician periodically evaluates the internal consistency of the equipment. And as we get used to more sophisticated equipment for testing, and there's an increasing demand on audiologists to know, to at least have the knowledge and the skills for the maintenance and calibration of your clinical tools. So calibrating equipment on a regular basis ensures that your measurements are accurate and reliable. And if you have an uncalibrated audiometer, of course, it's going to result in you misdiagnosing. And further, from a legal perspective, it's important, you're mandated, in fact, by state and federal agencies to meet some national and international standards. Some of the standards include the Professional Services Board standards by OSHA, and at a more federal level, it would be the Occupational Safety and Health Administration regulations. And you might find yourself in some legal trouble if if you were called upon to confirm the diagnosis of an individual. You need to provide evidence that you've been using a calibrated equipment, and there are some cases where one would need to show their calibration certificate and that they've been maintaining at least an annual calibration if there was any medical legal concerns. So when one is calibrating, of course, the main aim was to define the audiometric zero for any given transducer. It could be earphones, it could be insert earphones, it could be a bone vibrator, it could be your speakers. And there is this wrong notation that calibration is just for researchers. No. Calibration is important for any clinician, including clinical audiologist. And the initial calibration provided by manufacturers is not sufficient for doing justice to your patient and for medical legal purposes. In fact, some new audiometers are known to be even as much as being 20 dB off as soon as you open the box. So what does calibration entail? So there's two types of calibration, and the first type of calibration you guys are probably already involved in. That would be what we call as a biological calibration, or simply as a listening check. And this is the kind of calibration that you're expected to perform any given day that you will be seeing patients in your clinics. The second, more detailed calibration is what we call as an acoustical or electroacoustical calibration, which is required by federal and OSHA laws to be done at least on an annual basis. Of course, if you have a very busy clinic where you're seeing a large number of patients, and if there's more restrictive mandates like federal mandates, you might have to do more often than annually. For example, our VA clinic calibrates all their equipment twice a year, so once in every 6 months. So this acoustical calibration, the more detailed calibration, is done with the whole array of equipment. Of course, the star of all that you would use for calibration would be your sound level meter, along with a condenser microphone or a microphone. And then you'd have other devices that you would employ when you're connecting the different transducers of your audiometer to the sound level meter. These devices include a 2cc coupler or a 6cc coupler. The 6cc coupler is also known as an artificial ear. You could use an artificial mastoid if you're doing bone conduction calibration. You would use an accelerometer again for bone conduction calibration. You might use some filters. You might use a frequency counter, a voltmeter, and an oscilloscope. So accurate and reliable measurements are fundamental to characterize and for you to quantify the degree of hearing loss. And hence, of course, that is going to help you decide on the selection of hearing aids and for general health and safety monitoring. So in this slide, you're seeing some of the equipment that might be used in the calibration. So you have a sound level meter. These are one of those classical analog sound level meter, which kind of are actually huge and heavy. But until recently they were used predominantly. Now with the digital age, the equipment have reduced in size and weight. Some of you guys might have seen this around. This is an oscilloscope. Essentially, it depicts the input signal in the form of a waveform. This might be something that you use for calibrating the rise and fall time of your signals, of your pure tones. And sometimes you might even use it as a frequency counter for frequency calibration. This is an illustration of an artificial ear. This is something, it's also known as a 6cc coupler. Well, as a coupler, it serves the bridge between the sound level meter and the headphones of the audiometer. When you're doing insert earphone calibration, the coupler is actually a little more simple, and it's known as a 2cc coupler, and it actually looks like that. With one end connected to the microphone of the sound level meter and the other end connected to the tubing of the insert earphone. Here you've got an artificial mastoid. Again, when you're doing calibration for bone conduction, the signal, of course, is not acoustical, it's vibration. So you need something that converts this mechanical energy into electrical energy that is fed into the sound level meter. So you would use an accelerometer and this artificial mastoid to connect the bone vibrator to the sound level meter for the calibration of bone vibration. This is a voltmeter. At times you might use a voltmeter, so ensuring the input voltage for the audiometers. So essentially, what's needed, what makes audiometric calibration more specialized than for any other physical equipment calibration, is the need for these devices that resembles the outer ear's mechanical impedance. Okay, in other words, when you're placing the headphone on a person's ear or an insert earphone, there is a certain amount of impedance that's offered by this external ear for the sound that's emitted by your insert earphone and your headphone. So you need to account for that when you're calibrating audiometric equipment, and hence the need for these different couplers. For instance, when you're using an artificial ear, it's designed to mimic the mechanical impedance that's offered by the headphone when it's placed on your pinna. So not only it mimics the cavity space, hence it's a 6 cc cavity over here that simulates the cavity between the tympanic membrane and the diaphragm of the headphone, but it also, you need to simulate the tension of your headphone when it's placed on your pinna, and that's what this band does. Again, things are a little simple when you're using the insert earphone, but you still need to simulate that 2 cc cavity, which is the kind of the average size of the ear canal between the tympanic membrane and the diaphragm of the insert earphone. And for the adults, that approximates around 2 cubic centimeter, and that's what this cavity does. And again, it gets a little complicated when you're using a bone vibrator, because now you need to simulate the tension of the band of the bone vibrator, and the output from a bone vibrator is more mechanical nature. It's kind of vibration. So you need a device known as an accelerometer, which converts mechanical vibration into electrical output. That's read by the 711 meter. So you would not use a microphone when you're doing bone vibration calibration, because of course a microphone would convert acoustical energy into electrical energy. That's what you would need when you're doing calibration of the headphones and the insert earphones. But when you're doing a bone vibrator calibration, you would need an accelerometer that converts vibration into electrical energy. So let's begin by quickly reviewing what you guys are pretty much doing already, what we call as a functional listening check. So you'd start by you doing a hands-on thorough equipment check every day at the beginning, before the beginning, to see patients. Again, the purpose is to detect any hardware problems and to feel comfortable about the equipment working properly. This would include a visual check of the equipment. You'll check for the earphone band tension, see if it's any broken or if any of the earpieces have come loose. You check for the earphone cushions to see if they need to be cleaned, or if there's any puncture in the earphone cushions. You'll check the diaphragm of the earphones and make sure that it's not looking clogged. If you see something, any sediments over there, you want to remove that. You want to look at the cords and the connections, untangle the cords and make sure the connections are on the faceplate on the wall. Following that, you'll do a listening check. So you'll listen through the headphones. Most people will keep it at a comfortable level, say 30 or 40 decibels, and they would change the frequencies to make sure all the frequencies are heard right. You will increase and decrease the attenuator to make sure there's proportional changes in the amplitude. You'll listen to the tone quality. You want to hear a steady, clear tone. Another thing that you'll do is also do a crosstalk. You'll examine for crosstalk. So crosstalk refers to if there is any leak in sound in the non-tested earphone. So in instance, if you're checking the right earphone or insert earphone, you shouldn't be hearing anything in the left. So that's something that you need to verify. And you also need to verify while there's no presentation of the stimulus, there's no static, there's no background distortion, which usually indicates there's a poor connection of the cable on the faceplate. The following also should be attended to. So you want to check power, you want to check the earphones, you want to check the connections if they're fully plugged in. Of course, you'll do this frequency check, an intensity check, and you want to check if there's any tone in the untested earphone or insert earphone. Okay. Following that, you'll do what is known as a biological calibration. So essentially, you will verify whether the equipment is currently calibrated by comparing the hearing of a subject whose thresholds you previously know. And usually this is a person that is constantly in the clinic. That could be the clinician himself or herself, or it could be somebody who's working in the clinic. So this is to ensure that the audiometer hasn't developed a problem between those elaborate annual calibrations. And it's usually done immediately after the annual calibration. In other words, you'll get those thresholds or comparative thresholds immediately after you've done this annual calibration, because now you're confident that the equipment has been verified by the engineer and all the sophisticated equipment. You'll get the thresholds for this person that you're going to be checking with every day, every clinical day, and then that would be the baseline that you used for following comparisons. So immediately following the annual calibration, you'll record those baseline thresholds from this primary, and sometimes if you have the luxury, you might have a second listener also, just in case if the primary listener is not available any given day, you'll have a backup. So we would want to try to get a person with normal hearing thresholds, and so that would be the baseline. And when you bring this guy back for your daily calibration, you want to make sure that his or her thresholds do not change dramatically. So it's not more than plus or minus 5 dB. Up to 4 kilohertz and plus or minus 10 dB at 6 and 8 kilohertz. If the audiometer fails the static calibration, in other words, if those thresholds with no particular reason from the patient that you're using, you would check all the connections and the condition of the earphones and repeat this calibration. In case if the differences persist, then you would want to use the second person that you have in reserve. And if that was the same case for the second person, if the threshold seemed to have shifted dramatically or significantly, then you would perform this detailed electroacoustical calibration again. In the meantime, if that was the only audiometer that you have, in the meantime, what we used to do used to usually have like a cheat sheet where you would note the difference. For instance, let's say the person's threshold is shifted by 10 dB, has been worse by 10 dB, is made worse by 10 dB. Then your calibration correction would be minus 10 dB. So whatever frequency that it's off, whatever earphone it's off, you would use minus 10 dB as a correction factor for that frequency. However, if this person's threshold has changed in the lower direction, so instead of let's say 20 dB threshold, this person at one day its threshold seems to be minus at 10 dB. In other words, shifted minus 10 dB, then your correction factor would be 10 dB at that particular frequency. So whatever threshold you find for your patient at that particular frequency, for that particular transducer, you would add 10 dB to that threshold when you're plotting his audiogram. There's a number of simple reasons why you might have failed your daily calibration. Some of things that you can troubleshoot, or you could, if you have a reserve replacement you can replace, then you might find that you're back on calibration. And even in the hierarchy of likelihood, it could include an improper earphone placement, poor connections at the jack panel, so the connecting at the jack panel might have rusted or become loose. Worn out earphones. In case if you're using a portable audiometer, it could be just dead batteries. It could be the audiometer electroacoustical calibration is also expired. And one of the things that the engineer or whoever is doing this annual calibration would do is they'll typically have a sticker at the back of your the audiometer that's calibrated with the date in which it's either calibration is done or when it's due. So one of the things that you would you want to make sure if you're checking out portable audiometers, or if you move into a clinic that you're not familiar with, you want to look at the back and make sure that the equipment that you use has been calibrated within a year's span. And other things could be just the audiometer is malfunctioning and it needs to be repaired or replaced. Again, some of the things that you guys are probably familiar already about infection control and end of the day procedures. Of course, you would clean the earphones. However, make sure that you keep moisture away from the diaphragms of the earphones or insert earphones. You want to hang the earphones on the hook so it's not laid on the chair or something. So you will avoid those accidents with somebody sitting on it. And periodically, you want to replace the ear cushions, cords, or those patient switches, for instance. And if there's any data on audiometer, especially with those digital audiometers, you want to make sure that you back them up. And you want to properly shut down the system rather than just pulling out the plug. You want to make sure that you use the power button on the audiometer before you turn off the power for the whole room or such. Some more just things for your reference about critical audiometric equipment and non-critical audiometric equipment maintenance. So all this is that biological calibration.